Hello everyone, welcome to our session. Today we are going to discuss about the classification of palm oil or CPO from different sources using the spectroscopy tools and chemometric analysis. So palm oil, as we know, is the most consumed vegetable oil in the world. It covers more than 30% of the consumption of vegetable oils, and as a biggest consumed vegetable oil, it is also the most produced vegetable oils in the world. Also covers more than 30 to 35% of overall production of the vegetable oils. Now, palm oil has the biggest consumption rate, also the biggest production rate in the world. Palm oil also share very high yields of production, meaning they produce the oil palm tree produce in this case 30 in this data 36% of oil, but needs less than 9% of land. Now let's see at the map here. So basically oil palm tree is a tropical plant species. It thrives and grows on high rainfall, adequate sunlight and humid conditions. So this means the best growing areas are along a narrow band around the equator between 8 to 10 degrees north and south of the equator. Now, as you can see here, this is the Thailand's palm oil map, and we can see that the southern part of Thailand has more production of the palm oil than the central one. So at this point, we know that different locations can have different production, and uh, yeah. Now, not only location, but different times in the year also make a difference in production, as we can see here. Like in the top 10 producing countries of CPOs, they have different peak harvest period. For example, in Thailand, they have it on August. In Malaysia, they have it in November, and in Indonesia, they have it in October. So different location, different production, different time of harvest, also different time in year also uh, makes a difference in production. Now, Indonesia and Malaysia covers more than 80% of the world's palm oil production, with Thailand comes at the third at 4%. And you can see here the cumulative precipitation of Indonesia and Malaysia reach 3,000 millimeters. When we see the other three nations on the top 5, they are not reaching the 3,000 millimeters, especially Nigeria, even they only less than 2,000 millimeters. So there's a connection here between the precipitation and the production. So Thailand has a restriction for palm oil imports due to its protection on the local palm oil sector, and you can see why here. You can see that the price of Thailand CPO is higher than Malaysia, and it is obvious that it is because of the lower production. So the government make a regulation on import restriction, and this research area can support this regulation by preventing the smuggling of illegal imports. And yeah, the traceability also support the sustainable CPO production, which is the main problems in the palm oil industry right now. Next, this is one of the palm oil milling process flow diagram, and typically there is more than one of these. Depends on the design, depend of the raw material, depends on the design consideration, the location, and everything. uh, there is also probability that one palm oil mill have a different supply in the raw fruit punch, the fresh fruit punch. They can be comes from more than multiple plantation, and it is also a possibility that the breeding species is different. The breeding species is different. The treatment of the treatment of the plant is different. So because of this reason, the traceability of crude palm oil is a bit difficult. It's really connected to the palm oil supply chain because it's complicated. But the good things here, there are no chemical involved in the process of the crude palm oil milling process. So it really helps uh, the fingerprinting method. So the chemicals inside the CPO is not really complicated. Now, one thing of the fingerprinting or the traceability of geographical origin, we need to find a feature that connects between the CPO and the origin, the place. So there is a review on an AI framework for identifying the most effective palm oil prediction. This is a general palm oil prediction. Basically, they are using it for the palm oil yields. Uh, the majority of the studies rely on the environmental aspects, which is the climate, soil, and fertilization. And it is obvious, as we mentioned earlier before, that, for example, rainfall and precipitation really connects to the palm oil production. Now let's look the composition or the chemical properties of general chemical properties of CPO. Basically, the main chemical composition of CPO is triglycerides, about 90%, and less than 1% of monoglycerides, and less than 5% of diglycerides. There are also free fatty acids, which can covers the 3.5%. There are 0.225% of moisture and impurities, and we can focus on this, the last one, the 1% minor components, because we found that uh, we can see these minor components as a key parameters, as a key parameters that uh, connects connects between the CPO and the location, the origin. For example, here we can see different country of origin of the palm oil has a different carotenoids content. Yes, we can see Malaysia, Indonesia has a different carotenoids. So yeah, this is a great key parameters to put in the fingerprinting method. Now in 2012, Trash et al. are doing study about the application of fatty acid and VOCs, or volatile organic compounds, fingerprinting in combination of chemometrics to determine the origin of samples. They collected samples, about 94 samples of crude palm oils from 3 continents: the Africa, South America, and Southeast Asia. First, for the fatty acid fingerprint, they do the experiment to get the result from the samples, to get the fatty acids composition of the samples, and from the result they are doing the PCA, and the PCA scores plot shows a good result here. So they continue it to the partial linear square determinant analysis, which is the supervised algorithm geometrics, and as we can see here, it somehow shows a good cluster between the tree of the region. After doing the fatty acid fingerprinting, they are also doing the theosis, as we mentioned before on the title, using spectroscopy, which is a fast and non-destructive tools for gathering the data of the samples. Here, even without the chemometrics, we can see a difference between the samples from Southeast Asia, from Africa and South America, of the VOC, the volatile organic compounds here in the left hand side of the slide, and they put it on the PCA, the unsupervised PCA. The result is not quite good as before for the fatty acid. So they do you can say it's double layer here. So put they put Southeast Asia and non-Southeast Asia on the PLSTA algorithm, and after that they can found it, they can differentiate between the two, and after that they put the non-Southeast Asia as the Africa and America, and it showed a promising result on this one. They are also doing fingerprinting, but with different key parameters. They are using triacylglycerols or TAGs as key parameters, but they are using a different tools. They are using chromatographic tools, and this also shows a good result. So they are using HPLC to to see the TAGs from the different geographical origins of palm oil and compare them, and then they put it on the PLSDA, and yeah, they found also promising result. But this both of these two research are on the continent level. So uh, after this, we may need to search the one that have a more specific location of origin. So next up, the work by Muhammad, using 32 CPOs from one country but different, about six provinces. They are using 33 CPOs from Malaysia, and the samples are from Kedah, Perak, Selangor, Terengganu, Johor, and Sabah. So the study shows a good potential of using stable isotope as a key traceability parameter. So uh, on the experiment, they are using temperature conversion elemental analyzer isotope ratio mass spectrometer, or IRMS, to analyze the stable isotope profiles, and they distinct the cluster based on region. Firstly, they are using the unsupervised HCA, or the hierarchical cluster analysis, and after that they are using PCA, the unsupervised PCA, and we can see here, using the unsupervised PCA, it shows a good clusters here. So they are continuing the work using the supervised one, which is the OPLSTA, and the model shows a good prediction model and trustability. So the reason they also shows the reason why they are using this stable isotope signatures as key parameter, because from the study of these, the higher isotopic composition values are often related to regions with low elevation, coastal location, and warm climate, while lower values are associated with high elevation, inland location, and polar climate. So yeah, this is an interesting study. Next up is a study from Nigeria. They are using samples from a more specific region. They are using from one state in Nigeria, which is the Ondo state, but they divided into three regions: north, south, and central. So they are using 60 samples from there, and they are using two methods here. The one is quality characteristics, which is uh, will be yeah, later, quality characteristic, and the other method is using UV. The UV one, they are going to test the UV spectra. So you can see on the left hand side, this is the quality parameters that uh, they want to they want to analyze from the samples, mainly on the potassium or K extension values, the color density, and chlorophyll content. And yeah, and the second one, they are using UVVs on this spectra on 250 until 600 to get the result, the spectra. Now, for the first method, for the quality parameters, the PCI model on these quality parameters, the K extension values, the color density, and chlorophyll content shows a good promise. So they continue it to the PLSDA, to the orthogonal partial linear square discriminant analysis calibration model, and the score is quite good. As we can see here, the cluster, they found the cluster very well for every region. That is that also happened in the UV-Vis result. Whether it is untreated, you can see here the untreated spectral data for the PCA score is quite a bit mess, but we can see some cluster, and they continue it to the OPLSDA, and the even the untreated spectra is shows a good good a visibly good cluster, and moreover, when they treat the spectra data using SNV, the result show much better cluster. The other studies are conducted using different origin samples and different breeding species, different genotypes of this of the fruits. So it's conducted by Orsilo in 2021, and it's investigated the natural diversity in the carotene, the tocopheromanol, and fatty acid composition. And yeah, they found diversity in components. They found diversity in carotenes, the fatty acid composition, such as palmitic acid, and others, tocopheromanol, within the different place, different origin, and different uh, breeding species or genotypes. You can see here on his work, they plot the result on this one, and we can see here a good cluster, whether it is using different groups of location or different groups of genotypes or breeding species. You can also see the correlation between the carotenes content and the rainfall index. However, the rainfall index is not included in the paper, but we can search it search the data on the internet, and yeah, we can find some a bit correlation. Like in theory, we can say that the lower rainfall index, the higher carotene content it has. Now onto the latest one from Malaysia. They are using two different groups of sample. They are grouping the sample based on the meals location, and they are also grouping the sample based on the period of harvest, period of production of the CPO. And this one I show you the result on the different group, the grouping of by different location, meal 1 to 4, and we can see the cluster here visibly. And the paper also show us the what can be the influencing compounds that that can be put on the LV1 and LV2 for this OPLSDA chromatic method. So so we can see here, we can connect it to the mean monthly rainfall. Also, this one is not from the paper. I got it from the source in the government site. And we can, let's say, we can group the four meals into two groups, which is the one with lower and high rainfall index. So we can see it on the LV2 here. We can focus it on the LV2, and we can find the main contribution uh, to the OPLSDA LV2 is the number 6 of the spectral regions. The number 6 and 7 is the single bond CH2 cis, this substitute olefins and saturated fatty acid group. Now, how chemometrics aid in CPO classification and traceability? So, data handling with chemometric approach, we're discussing about this. So, in doing this CPO fingerprinting, you can see the concept of using spectroscopy tools here. So we prepare the samples, which is the CPO or other organic samples. If we have like other project. In this project, we are going to have CPO fingerprinting. So we need CPO samples, and we do the fingerprinting techniques to get the data matrix. This data matrix can be or can be not pre-processed before going to the chemometrics, and you can see it. So let's see in this illustration the analytical techniques, which is can be chromatographic, can be spectroscopy tools. We got from these techniques the raw data, the data matrix, and then the data can contain information, noise, and everything. So we put all of the data into the chemometric tools. We can also do some pre-processing such as SNV and normalization, smoothing, and everything. So the chemometric will analyze the data and give us information that we want to have. So let's see the example here on the right hand side. Fingerprint example using FTIR. For example, the middle one, they has a noise and everything, so we need to pre-process it, and then we got into the PCA and everything. So basically, geometrics help us in data handling, data processing, so we can get the result that we want as an objective. The analytical tools that we are going to use uh, Raman spectroscopy, see, because Raman is a remarkable technology. It has high sensitivity, it has high spectral performance, it is rapid. We can get 80 spectra in like 15 minutes, less than 15 minutes or seconds, in seconds. And yeah, and we do not need to do sample preparation since it is unaffected by moistures in samples, so it highly precise. The second one is FTIR, the Fourier transform infrared spectroscopy, which also rapid. It can, depending on how many scans that we want to do, it can be in seconds or in minutes. But it has lower 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 speed than Raman. It needs more time, and it is very sensitive to homogeneity, and uh, it is also sensitive to the humidity of the environment of near the tools, but it is non-destructive also. It's swift and it's cost effective because it's like cheap and it's available everywhere in the world. The third one is UVVs. UVVs need some treatment for the sample. We need to mix it with the base, with the solvent. So yeah, basically these are three spectroscopic tools that is more rapid, faster than any chromatographic. Which for chromatographic, it can take like more than 30 minutes or something for one sample only. So yeah, the future works. So right now we have a collection of Thai samples, about 50 or more than 50 samples from uh, many provinces. We also have samples from Indonesia, from four provinces in Indonesia, and yeah, basically we need to reach more samples more to get bigger library of data. So this one is the result of FTIR run on Thai samples. So we put this one is in order of the rainfall index. We take one sample from each province and we sort it by the rainfall index order, and the the result that we want to have is, by theory, is we want to have a lower carotene uh, content on the higher rainfall index, and yeah, basically we do the FTIR here and then we normalize it. We smooth, we subtract the baseline, we normalize, and all of the pre-processing, and yeah, we want to have that visually, but we need to do the chemometrics also using this data, whether it is like untreated or pre-processed before. I think that's all from my presentation. Thank you very much, and we acknowledge all the contributors, whether it is the researchers and the providers of our work. And yeah, thank you very much for the attention, and we are open for discussion and maybe suggestion if you have any. Thank you very much.